Okay, this is a exercise 3 question 10, also the application question. The equilibrium state of the force balance between balance equation of an arrangement of 4 spring. A spring with the, I think this is a what now? The elasticity constant K1, K2, K3, K4, and is given by the system of linear equation here. This one. You have, okay, 4 unknown, 1, so you should have 4 equations. So 1, 2, 3, 4. Then you just need to, actually you just need to plug in the value of K1, K2, K3, K4, and F. We have forms system of linear equation with 4 unknowns. Then you just need to plug in the value K2. Okay, is a Newton per meter, so Newton. So you plug in K2 80 times x2 minus x1. K1 is 50, so 50 x1. Okay, and collect together the x1 term. So we want to collect which side? Let's say you collect, okay. Never mind. So negative 80 x1 collect with a negative the left hand the right hand side 50 x1, so you have negative 130 x1 plus 80 x2 equal to 0. This is the first equation. And then plug in K3 equal to 100 into the second equation. So you have 100 x3 minus x2. K2 is 80 x2 minus x1. So make sure you plug in correct 100. This is 80. Okay, and collect the same term. So x1, I bring everything to left side. This one I bring left side, this one left side. So minus 80 x1 bring to left side, become positive 80 x1. Then x2, you have a 80 x2 bring to left side, so minus 100 minus 80 minus 100 80 x2. Okay, and then okay, x3 is 100 equal to 0. Equation 2. So when you expand or collect, make sure you double check before you go to solve the system of linear equation. Okay, now okay, go to the third equation, plug in K4 is 200. So K4 200, x4 minus x3, K3 is 100, so 100 x3 minus x2. So collect the x2 minus 100 in left side bring to left hand side become positive 100 x2. Okay, and the x3 positive 100 collect to left side, so minus, so already minus 200 minus 300 x3, and then plus 200 x4 equal to 0. Okay, before you make sure you check 80 50. Okay, correct. The second equation, K2 K2 K3 is 100, K2 is 80. When checking before you solve it. This is positive minus minus, correct. The third equation, K4, this is 200 x4 minus x3, K3 is 100. Okay, collecting the same term, 200 x4 x3 you have minus 200, right side minus, okay, so minus 300, x2 minus, bring to left side positive. So this is equation 3. Okay, equation 4, f equal to, so plug in f, 1000. Okay, k4 is actually 200, so 200 x4. You have 200 x4 minus x3 equal to f. F is 1000, 1000, right? 1000. 200 x4 minus x3. Okay, expand it. You have negative 200 x3 plus 200 x4 equal to 1000. So you have 4 equations. Okay, if you want to put into the system, let's say x1, x2, x3, x4, this is the B. Okay, equation 1, negative 130, x2, this is 80, this is 0, this is 0, this is 0. Second equation, x1 is 80, x2 negative 180, x3 is 100, this is 0, this is 0. Okay, the third equation start from x2. So x1 is 0. Okay, x2 coefficient is 100, x3 is negative 300, x4 is 200, right side is 0. Okay, equation 4 start from x3 is negative 200. Okay, and then x4 is 200. Okay, the right hand side is 1000. So this is 0, this is 0. Okay, may I know, okay, what is the metric A is which conditions? Siti no Diana. Siti no Diana. Siti no Diana, are you around? Can you tell me whether the A is it 3 diagonal, symmetric positive definite, or diagonally dominant? Siti no Diana, are you around? Siti no Diana, are you around? Siti no Diana, are you around? Siti no Diana? Siti no Amalini?
Yes, doctor.
Okay, is this one 3 diagonal or symmetric positive definite or diagonally dominant? Which one? Or no condition? You may type on the chat, or anyone know what condition for this metric A also can type to the chat box there. Yes, no Tira, Sobana, Fuad. Yeah, 3 diagonal, correct. No Tira, this is 3 diagonal. Metric A is 3 diagonal. Because 3 diagonal, you see you have only 3. Start from diagonal. Why? Because 3 is mean 3 lah. 3 diagonal. This is 3. Okay, diagonal you have 1 row. Here, 1. So only three, okay, only, okay, start from diagonal, upper diagonal, bottom diagonal, you have value. The rest are 0. So this is 3 diagonal. So this system, you can solve it using, okay, if 3 diagonal, can solve it using which method? Which method? Okay, anyone type it, okay, to the chat. Thomas, correct. Yes, correct. 3 diagonal, you can solve it using Thomas method. Okay, of course, okay, any linear system, you can solve it using Gauss elimination method. And then this case, I think if you solve Gauss elimination with pivoting, okay, no need to swap, okay, for first column, because when you take the magnitude A11, this is already maximum. So you can always solve using Gauss elimination method. Since this is 3 diagonal, you can solve it using Thomas method. Okay, and then you see the diagonal, you have a negative value. So, okay, if negative value, so this is not, is, okay, even this 80, 80 symmetric, 100, 100 symmetric. This is positive 100, this is negative 200. So it's not symmetric. Also not, because 200 and negative 200 here. So one is positive, one is negative, so it's not symmetric. And the diagonal, you have a negative value, so it's not positive. So you cannot solve using Cholesky. Cholesky cannot. Okay, how about, is this system diagonally dominant? Is it diagonally dominant?
No, doctor.
Okay, diagonally dominant, let me check whether it's a magnitude. This is, have to check whether it's greater or equal to summation of, means summation of Aii, Aij, where the j from 1 up to n. Okay, first row, when you take magnitude 130 is greater than 30, 80 is okay. Second row, when you take, okay, magnitude of negative 180, and then this is 80 plus 100. Okay, this is equal. Have to check, okay, back the condition whether this is greater or greater and equal. Okay, let me check back. Hold on, let me check back. So it's greater. The magnitude Aii is greater than summation of magnitude Aij. Okay, and then the j cannot be equal to ij from 1 to n. Greater. Must be greater. So mean this one, magnitude A22 is 180, but this one, magnitude A21, 80, A23, 100, add up, they are equal. So cannot, because this one is greater. So this is also not diagonally dominant. Because if, let's say, one entry not satisfied, is automatically not diagonally dominant. Because if third row you check also, this is magnitude is 300, this is 100 plus 200 is 300, equal, also cannot. Okay, the fourth row also, this one magnitude 200, and then this one 200, they are equal, so not satisfied the criteria. So this one is only, you can solve it using Thomas, and you can always solve it using, okay, using the, okay, Gauss elimination method. Okay, but you can always, okay, provided you use, okay, this calculator, mean to check, okay, the solutions, to check the exact solution. Okay, if 4 by 4 system, you still, okay, can use this class width calculator to obtain the exact solution quickly. So there's a guideline for you to check with your, later on, let's say you use Thomas method. Okay, so you can just quickly, okay, key in the system to your calculator. And then this is 80, negative 100, 80, 100, 0, 0, third row, 0, then you have 100, negative 300, 200, 0, then 0, fourth row, 0, 0, negative 200, 200, and then 1000. Okay, before you press equal, double check whether you key in correctly. Vector B, the last column. Okay, only the fourth row, okay, is 1000. Okay, the X4, okay, in calculator is T, 0, 0, 200, okay, 200, 200. Okay, the third column in calculator is a Z, 0, 100, negative 300, negative 200. Okay, column B, column 2 in calculator is actually the, sorry, this is column, I think I key. Okay, go back to the first column. Column 1 is X1 is X, negative 130, 80, 0, 0. Second column, okay, second column, 80, negative 180, 100, and then 0. Okay, third column, 0, 100, negative 300, negative 200. Fourth column, 0, 0, 200, 200. Last column. Okay, make sure you key in correctly, only you press equal. So we obtain x1. So you have actually x1, x2, x3, x4, 220, 32.5, 42.5, 47.5. Okay, check with the solutions. Question 10. Forty-seven point five, 42.5, okay, 32.5, 20. Where is it? Okay, this is using calculator directly. And then you may, okay, practice using your Thomas method. Thomas method. Okay, and if 4 by 4, your Thomas method. Okay, let me show you. Hold on. Okay. Okay, for 4 by 4, your Thomas method. Okay, the A here, you put up the A, and then Thomas method is actually is a, okay, LU okay, decomposition method or factorization method, mean you decompose A into L and U, okay, and L is lower triangular matrix, okay, suppose mean only lower, okay, lower part consists of value, okay, suppose it's only lower part consists of value, okay, but because, okay, Thomas method, the system is actually three diagonal, right? So normally L is actually, okay, okay, this, okay, normally the lower triangular matrix, this, okay, A31, A41, A42 should be cannot be 0, but because the A is 3 diagonal, because this 3 value is 0, so that's why this part must be 0 too. So that's why for your L is only A, B, C. Okay, can you see, right? A, B, C, D, E, F, G. And U is actually uh, upper triangular matrix. And for the U in Thomas method, it's actually diagonal of U must be 1. Okay, and because, okay, your A is 3 diagonal, A is 3 diagonal, so upper part, these three value A13, A14, A24 is 0. That's why this part must be 0. And this part 0 is follow here. Then this one 0 because you follow this. So that when you multiply L and U, you get back, okay, 3 diagonal. So this is a Thomas method, okay, for 4 by 4 system. Later on, you do the metric multiplication, compare element by element. You will get, okay, all the A, B, C, D, E, F, G, H, I, J. And then second step, okay, solve for y from Ly equal to b. Okay, of course, okay, this one to get quick answer, you no need to do manually forward. Okay, forward substitution means you start from, okay, row 1. Okay, forward substitution, you start from row 1, then you solve to the back, okay, to the last equation. Okay. Cannot write, never mind. Then, okay, step 2, you may key in into your, okay, equation mode in calculator to obtain the vector y quickly. And then the step 3 is actually from ux equal to y. Ux equal to y they obtain in step 2. Also, you can, okay, you no need to solve manually backward. You may key in into your system. Backward is actually you start from the last, okay, equation, you solve until your x1. You can also directly using the equation mode in your calculator to obtain the answer quickly. Okay, and this case emulator, if you never, okay, download it before, you can download it and use it for 90 days. 90 days as well. I have, okay, give to you through the Telegram and also in the, I think, in the, okay, poster of the talks, okay, that I'm going to give this Thursday. You have the, okay, the link for this emulator, because you can solve up to system of 4 linear equations. So this is the, okay, which questions? Okay, exercise 3, question 10. Application questions. Question 10. Question 3 also similar. Okay, like question 10. Plug in all the K1, K2, K3, and the M1, M2, M3. Okay, and this one is in the nice form already, your U1, U2. Okay, so U1, U2, U3, U2, U3. Okay, they already collect the coefficient for U1, U2, okay, U3, so that not like, okay, this one you have to collect back yourself, okay, for the, okay, the coefficient for, okay, in terms of the x1, x2, x3, x4. So there is a question 9, and then question 8. Yeah, but time's up. Question 8 also application question. You have to, from the statement, you have to form into the system of linear equations. So, okay, we consider, okay, finish the exercise 3. Yeah? So next tutorial we'll do the exercise 4.